So remember yesterday we talked about what logarithms were, that it's the inverse of an exponential function, right? Exponents and logarithms are inverses. Yesterday we moved them back and forth from one to the other. We manipulated the numbers and changed them around so they would be close to the same. So today we're going to do two things. We're going to look at, I think, 4 more properties of logarithms, and then we're going to do something called change of base. Which the change of base formula is beautiful. It's wonderful. It's fantastic. It's what allows you to put these in your calculator. It's a glorious thing. So that's what you want. You want to be able to put them in your calculator. It makes it easy. Actually, with the calculators that most of you have to use change of base. The new calculators, the Inspire, you don't need the change of base formula if you have an Inspire. You know that app that we all downloaded, like almost everyone downloaded, the calculator app, and it was awesome? Do y'all have that one? Okay. I don't know if it needs change of base formula or not. It may not. We'll play with that in just a little bit and see. We'll see. Okay, so let's look at the product property. The product property for logarithms. We're going to look at why we need these also. I have a chart. The product property says that if you have two numbers multiplied together, log base b of m times n, then you can split that up. You can expand that to log base b of m plus log base b of n. So why in the world do I care? Well, here's why I care. You'll care more later. Remember the chart that I was telling you about? Okay, the chart only goes up to 9.9. That's as far as the chart goes, okay? That's it, goes up to 9.9. So what if I needed to know, like, log, let's see, 48. Log of 48. 48's not on my chart. It's nowhere on here. 6 and 8 are, right? So I could say, well, that is the log of 6 times 8, which is equivalent to the log of 6 plus the log of 8. So I go back to my chart, and I pour over my chart, and this one is 0.7782, and this one is 0.9031, and now I can just add those two together, and I have the log of 48 without having 48 on my chart. Pretty awesome, right? I can find out what they are without actually having them. Now, you have the wonderful gift of a fantastic calculator, so you may not need these. But for those who don't, that's what we use it for. So that's the product property. Product property uses addition. Pop quiz. Guess what the quotient property uses? Subtraction. Dang it. Well, the quotient is division, so we expand it into some subtraction. So the quotient property says, quotient property, we use an M and N, yeah. You have log base b of m over n. That would be like log base b of m minus log base b of n. Again, why do I care? Well, What if I need log of 0.5? What if I'm not on my chart? My chart goes from 1 to 9.9. Can I create a quotient that is equivalent to 0.5? Well, yeah, 1/2, 1/2. So that would be equal to the log of 1 minus whatever the log of 2 is. So go to my chart. Oh, look at that. There's 2. Yeah. And then I would do my subtraction, and that would be my answer.
So did you say that was a January07?
Mm-hmm.
What is that in front of the decimal?
It's a 0. It's just a little loopy one. You get it. Okay. Power property. Can I move this one, by the way? Alright, power property is a really good one. We use power property quite a bit in our other classes. It says log base b of m to the p is equal to p times log base b of m. So let's say I'm looking for log of 25. Okay? 25 is on the chart. I'm going to rewrite this as log of 5 squared, which would be equal to 2 times whatever the log of 5 is, or 2 times 5. And that would be the log of 25. One thing that we're going to do, I'm going to show you the change of base. I'm going to show you how it can go in your calculator. And but at the same time, at some point, you are going to have to use the chart, because I mean, this is simple. Really, it's simple math. Realizing that 25 is 5 squared. Knowing that you can break 48 up into 6 and 8. But when you have to make your brain change those numbers and look for those patterns, you really develop number sense and reasoning. You really need to know how to reason. Okay, you need some reasoning skills. You are about to go away from your parents and have to make some decisions on your own, and you need some reasoning skills. So we are going to do this. You need to know how to think, and this really makes your brain think, okay? Like, some people need to think that it's not wise to fall asleep in algebra. You need to know how to think. So we're going to do this, even though I'm going to teach you how to do it in the calculator. We're going to do it on paper too, okay? All right. Just a couple of other quick properties. If two numbers are equal, if m equals n, then that implies that their logs are also equal. And this is going to help us more when we're solving equations than you won't just like use that. That's going to be more solving equations. And then the opposite is also true. If the log base b of m equals the log base b of n, then m equals n. So those are going to be handy a little bit later on. Okay? So let's start just trying to expand some logarithms. You have these two written? No? Okay. Yes.
On the prior property one, I think it's like 5Q. Did you just write 3?
3 times. Yep.
So no matter what it is, you just put whatever the next one is.
Yep, it just moves to the front. Yes. Okay, so let's say we have log base 5 of x y squared. We would like to expand this, okay? First of all, the product, that's multiplication. So what can I do to expand the product? Right? Log base 5 of x plus log base 5 y squared. Is there anything else that can be done to this with our properties we just learned? Yep, that 2 can come to the front. Log base 5 of x plus 2 log base 5 of y. Exactly. Alright, let's try another one. This one's uglier. See what it be. Okay. Let's start with the division. What can we do with the division? Subtract, so I can say the natural log of e times the square root of y minus the natural log of z cubed. Yep, I can rewrite this as y to the 1/2. What can I do with this? That's e times the square root of y. What do we write for multiplication? Yep. So it's going to be natural log of e plus natural log of... Yeah, we'll move it to the next step. Anything over here? Yep. Does anybody remember the base of natural log? That's common log. Natural log's base is e. So what we're looking at is that. Remember from your basic properties yesterday what that equals? Yep. 1 plus. Now where does this 1/2 go? Yup. That's your answer. That is fully expanded and simplified.
So anytime it has an E, it'll be natural log.
Yes. Yep. Alright, I'm going to give you a couple of try. I'm just going to give you one. I'm going to give you one try. I'll just put both things in it. Alright, let's take this step by step. What do I want to do first? Subtraction. Okay, so log 100 minus log xy cubed. What else? Alright, log 100 minus log x plus log y cubed. Okay, move the 3. Alright, anything else?
Times 10 squared.
Yes. Log 10 squared log x plus 3 log y. And then this just becomes 2. Exactly.
Why is that such a
It's a common log, so the base is 10. So log base 10 of 10 is 1. You just have that 2 that's right there. Because remember, that's one of your basic properties that we did yesterday. So that's expanding. Now let's condense them. Let's shove them back together. Yes.
I took the extra part.
Because multiplication is addition.
Oh, okay. Yeah, I get that.
Yep. Now we're going to take one that's spread out, cram it back together. Okay? Alright, now, and I want to do this one because I want to draw your attention to something, okay? This natural log parentheses x plus 4 is not the same thing as this. That's not the same, okay? On this one, you are taking the natural log of x, you're taking the natural log of 4. This one, you have to add 4 to this number and then take the natural log of it. They're not the same thing, okay? So just remember that. These, not the same. Okay? Not the same. We need to get out of the way though. Okay, so we need to start putting this back together. Let's just go step by step. Do that step by step. Like this 2. Where can I put this 2 that's in the front? Uh-huh. So I'm going to have right there. Okay. I can move this. I'm going to do it a step at a time. Move that there. Okay. And then, yeah, I can change that to a square root. Like so. Yeah, and then multiply them together. Natural log, I'm going to put parentheses. That's a whole lot going on. Of all of this. So we just condensed it. Step by step. Take it step by step. Alright? You ready for another one? It's going to be like 12 miles long. Are you prepared for that? Psych yourself up. Alright, yeah. Alright. What? I think that's it. Okay, take it step by step. What are you going to do first? I think probably the first thing I would do is take care of that 3. That's going to be the easiest to do. Nothing else really changes right now. Okay, what does this addition mean? You're multiplying these two together. So that's log base 5 of x squared minus 4 y cubed. And what is that subtraction mean? Yeah, you're dividing it. Okay. Log base 5 of x squared minus 4 y cubed over x minus 2 squared. That can actually be simplified. If this factors to x minus 2, x plus 2, it's going to cancel one of those out. So your final answer is going to be x plus 2 y cubed over just 1. That's your final answer. Gosh, we're still having a factor. Oh. Yeah, unless you go to college. Oh, yeah. Oh, okay. Alright. So that's expanding and condensing. The last thing I want to show you is change of base formula. Alright. So most calculators, only use the common log, which is base of 10, or natural log, which is a base of e. Change of base formula says that you can figure this out. Like, this can't be put in a it can be put in like a super fancy calculator. This can't be put in a regular calculator. So if this was like log base 12 of 17, you're like, I can't do that because I don't have my chart to base 10 and the calculator's base 10 or it's base E, so I cannot do, what did I say? Log base 12 of 17, which actually you can't, because the change of base formula says that you can divide any base and get that same answer, okay? You get to choose the base. So you could do log base 10, which your calculator will do, which is the common log of 17 over the log of 12, and it would give you whatever log base 12 of 17. Or you could say the natural log of 17 divided by the natural log of 12, because natural log also works, and it will give you whatever this was. So that's a change of base formula, which it's also very useful with the chart, because if I needed, log base 6 of 4, then I could go to my chart and I could say, okay, well, the common log of 4 is this, and the common log of 6 is on the next page, is this, and I could divide those out, and it would give me whatever log base 6 of 4 is. So it's still useful even with the chart. It's just fantastic, though, with the calculator, because I still have to divide that out with my tiny little calculator that can only push buttons with lead of a pencil. So, anyway, it's still much better. So that's a change of base formula. Biggest thing to remember is this number goes on top, the base goes on bottom. That's easy to remember, that the base number is going to be on bottom. That's where base is, base is on bottom. So that's easy to remember. So that's change of base. Okay? Super easy stuff.